start recording. We have lithium nitrate, LiNO3, and we have sodium chloride. A few of you are really excited about activity series and predicting reactions. You don't know enough yet to predict whether or not a double replacement reaction will occur. We have only talked about activity series for single replacement reactions. Double replacement reactions, we don't gain that skill until about chapter 14, so don't get too excited. And on the front, the directions were just to name the reaction, predict product balance, so we weren't looking at whether or not it would. I will admit, yes, the single replacement there wouldn't actually run, but the goal there was just predicting. So I'll try to remember to double check all of my reactions on the test for realism. So we have lithium nitrate and sodium chloride. If this reaction were to run, we would end up with these two products. There's only one type of reaction it can be. You've got two binary ionic compounds. This is a double replacement. Sometimes called double displacement. It doesn't really matter. / double displacement. And a few people, I forgot to put reaction types, and I don't know if that was just a forgot it or confusion, but make sure you do that. So for the next one, the first thing that you notice is that there is only one reactant. There's only one kind of reaction this can be, and this is a decomposition. Whoops. Okay. The only two products possible are iron and oxygen. And the single most common error here is people want to write Fe2 plus O3. Can't do that. You have to write correct formulas. For pure iron, the correct formula is just Fe. For oxygen gas, the correct formula is O2. And that is the single most common mistake with decomposition reactions. So please make sure you're writing correct formulas for all your products. This first one was already balanced. To balance this one, we have to do 2 of that, 4 of that, and 3 of that. So 2, 4, 3. And of course, if you don't have correct formulas, you're not correctly balanced either. Okay, number 3. This is the single replacement that, yes, in reality would not run because chlorine is more active than, or less active than fluoride. But we're just predicting products here, so if this were to run under some sort of weird conditions, that's what we'd get. We're swapping out one dance partner. This is a single replacement, or single displacement. And to balance, we just need to do that, and we're done. Okay. So 2 ammonium fluoride plus 1 chloride yields 2 ammonium chloride plus 1 fluoride. Okay, number 4, we have only 2 products, magnesium metal and oxygen. And this is a synthesis reaction, so it forms MgO. To balance that, it's 2 magnesium plus 1 oxygen yields 2 magnesium oxide. Remember how we said some reactions can actually be 2 different types of reaction? This is most commonly looked at as a synthesis reaction. It's also a combustion reaction, though. So it is also combustion. It's not the kind of combustion we think of. This is not necessarily, magnesium can oxidize over time, but if this is happening at a clip, this is a combustion reaction too. You're oxidizing magnesium. So on the test, typically once we've talked about this explicitly, I expect that you'll remember that, and that, when you've got the oxidation of a metal, it can also be considered combustion. Okay, the last one. This is propane. When you take propane and you mix it with oxygen, guess what you're doing? You're combusting it. So this is the combustion of a hydrocarbon. There are only 2 products for the combustion of a hydrocarbon, and they will never be anything else, and they are always CO2 and H2O. Okay, So it's combustion. Those are our products. It's not the only kind of combustion, but it's one that we have talked about a lot. So you should recognize combustion of hydrocarbons and be able to balance them. People want to make this like a single replacement and swap out the oxygen and the hydrogen. Can't do that. Okay, to balance this, C3H8 plus 5O2 gives you 3CO2 and 4H2O. Okay. Questions, comments, concerns on the front part? Okay. For the most part, people did pretty well on the front. For A, we have silver iodide and chloride. Will this run? So what could chlorine replace if it's going to replace anything? The iodine. If it's going to replace anything, it's going to replace the other halogen. Chlorine is more reactive than iodine, so we get silver chloride, and we get iodine. To balance, we have to do that. Whoops. That. Okay. B, zinc chloride, ZnCl2, and copper. So what could the copper potentially replace? The zinc, the other metal. Which one is more active? The zinc. So no reaction is going to occur. This is not going to replace zinc. C, we've got sodium chloride and bromine. And which element could the bromine replace? Chloride, because they're both halogens. And bromine is less active than chlorine, so no reaction will occur. Okay, D, we have aluminum fluoride, and we have iodine. Which element could the iodine replace? The fluoride, because it's the other halogen. Will it? No, iodine's less active than everything, so iodine never gets a shot. Okay, E, we have sodium sulfate, and we have lead. Well, what could the lead replace potentially? The sodium, the other metal. But lead is less active than sodium, so no reaction is going to occur. Okay, let me shrink these to get myself some room here. Oops. Oops. Okay. So F, we have silver chloride, and we have copper. What could the copper potentially replace? The silver, because they're both metals. And copper is more active than silver. Silver's pretty non-reactive, so we get pure silver and copper chloride. Now, a couple people in the other class said, well, which copper is it? Is it copper 1 or copper 2? How do I know? You don't. So you can write it either way, as long as you're consistent and you balance your equation. I myself tend to, when given an opportunity like that, write it in such a way as that I don't have to balance anything. So if you write it with copper 2 chloride, you're already balanced. If you wrote it with copper 1 chloride, what do you have to do? AgCl2 plus 2Cu equals Ag plus 2CuCl. That's not bad, but yeah, I tend to, if I have an option to write it with an ion that allows me to just be balanced already, I take it. And part G, we've got iron nitrate. You can buy iron nitrate in the lawn and garden section at most hardware stores. It's applied to lawns very often as a moss killer, but it also gives the lawn this like real burst of green because the nitrogen is taken up by the grass and it goes woohoo! It's a party. Okay, so what could the zinc potentially replace? The iron, because that's the other metal. And zinc is more active than iron, so we're going to get a replacement, and we'll have zinc nitrate and pure iron. Okay, questions, comments, concerns?